What are oxidizing and reducing agents? Let's try and answer that question in this video. Your textbook has this image where it talks about how copper gets reduced and hydrogen gets oxidized. But how do they get to those steps? The very first thing I do is I look at every single atom that is present in this balanced chemical equation and I determine what is the oxidation number for that atom. So meaning copper oxide, which is our first compound, copper is going to have a 2 plus charge and oxygen is going to have a 2 negative charge. How did I get there? Remember, oxygen is always going to be 2 negative, and therefore copper has to balance it out to make the whole thing have a charge of 0. If you need to, go practice your oxidation numbers first. For this video, we're going to assume you know how to assign oxidation numbers. So stop the video, pause it, and assign oxidation numbers for every atom in this equation. You should have had copper oxide, so copper is 2 plus, oxygen is 2 minus, hydrogen is 0 for reactants. For products, copper is now 0 and hydrogen is now plus 1, which means your copper went from a 2 plus charge to a 0 charge. It was reduced in charge. While at the same time, hydrogen went from a 0 to a positive 1, so it was oxidized. It increased oxidation state. So in this equation, we have a couple ways that we could call each of the atoms. You've got reduced, you've got oxidizing agent. You've got oxidized, you've got oxidizing agent. And so what do you call each one? And then there's also extra atoms that don't play a role in the oxidation or the reduction. In that case, this is oxygen, where oxygen is -2 as a reactant and -2 as a product. It stays unchanged. So what we do is, in summary, we never change the oxidation state from oxygen from -2. So it was neither reduced nor oxidized. Copper, it went from 2 to 0. So we could either say copper was reduced or a reduction reaction occurred for the copper, or copper was the oxidizing agent. Okay? You have to use reduced and oxidizing agent. Those are the two key words that go with copper in this equation. For hydrogen, it's the opposite. Hydrogen goes from 0 to plus 1. So hydrogen was oxidized, it increased in oxidation number, or it's the reducing agent. But you'll notice reduced always goes with oxidizing agent, and oxidized always goes with reducing agent. And for everything that is reduced, you need something to balance it out, and you need something to be oxidized. So what we're going to do is we're going to do two equations to practice. The first one is shown here, where we have 2 carbons plus oxygen to yield 2 carbon monoxides. So the first thing I want you to do is pause the video and determine the oxidation number of every atom in this equation. To begin with, you should have known that carbon does not have an oxidation number stated, so it must be 0. And at the same time, oxygen is all by itself. So there is no other element in there, and so oxygen is 0. Now you might have been tempted to put oxygen was -2. Remember, for oxidation rules, you have to look back and you have to remember that if oxygen is ever by itself, so no other atom is present with it, and there's no charge indicated, then it's always 0. Then for carbon and oxygen, now in this case oxygen is -2, which means your carbon has to be +2 to balance it out. Then try and fill in the following blanks. I always do my reduce first because it's easier for me to see when a charge goes down, and that's reduced. And then I fill in oxidized as the opposite. So we know one of these is reduced and one of these is oxidized. To help you out, remember that carbon goes from 0 to +2, and oxygen goes from 0 to -2. So pause the video, try and fill in these blanks. So what you should have said was that oxygen was the one that was reduced because it went down in charge. It went from 0 to -2, which means by contrast, carbon has to have been oxidized. It increased its oxidation number, which means if it's oxidized, it becomes the reducing agent, and oxygen becomes the oxidizing agent. Let's try another one. This is a much more complicated equation. What I want you to do is I want you to pause the video. For real, pause it, and try and determine the oxidation number of every single atom in this equation. These are the results, so check your results and see how you did. At this moment now, once you've checked them and you agree with my answer, then what you should ask is what stayed the same and what changed. When I ask that first question, what stayed the same, what I'm looking for is what element on the left has the same oxidation number on the right. So if you notice hydrogen has a +1 on there as a reactant and a +1 as a product. So we're going to ignore all of those oxidation numbers because those did not change, which means hydrogen was neither oxidized nor reduced. I'm trying to figure out which was oxidized and which one was reduced in this equation. Did anything else stay the same? I hope you noticed that oxygen also stayed the same. In nitrate, it is a -2. In sulfate, it's a -2. And in water, oxygen is also a -2. So that means oxygen nor hydrogen were reduced or oxidized. So now let's look and compare reactants to products. So here sulfur changed from -2 to a +6, and nitrogen changed from a +5 to a 0. With that being said, I want you to pause the video and try and fill in the following blanks. Now, once again, I always do reduce first. That's just me. So I like to be able to see things just going down. So which went down, +5 to 0 or -2 to +6? Hopefully you saw that +5 to 0 is a reduction, so nitrogen was reduced, which means sulfur was oxidized, and nitrogen is the oxidizing agent, and sulfur is the reducing agent. So anytime you're asked to define an oxidation number, if you can do what is shown in this slide, then you should be able to do any equation. Now go read section 8.3 to see how this is utilized.